So I'm going to go through question 1 on page 197, 198, actually the 198 part, exercise 6.5. It's on geometry, and there's a few rules in here that are really important. So the first, I'm going to start with part 4 here, and we're going to go and work our way through from there. So if you take this, they're giving you the angle of 80 degrees here, and they're asking you to find the angle A and the angle B. So that you can see that they're giving you the angle 40 degrees down here. Now, the first thing that you are going to know is that this angle A here is exactly the same as this angle 40 over here. And the reason for that, if I put this into red marker and highlight what you have here, is if you look at that angle 40 here, and let's say this angle in green over here, both those angles have a common base. So they start at this point and finish at that point. Because of that, they're both equal angles. So we know starting off that A here is 40 degrees. Now, for angle B, you know that this is an isosceles triangle. So that length between O and out to here is exactly the same length as this between O and down to that point down there. They're both radiuses, so it's an isosceles triangle, which means that B is also equal to 40. Okay, just as a matter of interest, you also could have got that angle A there from knowing that this angle here is 80 degrees. This is going to have to be half of 80 degrees, because again, this angle and this angle share the same base, but the 80 degree angle goes to the center, and the other angle, when it goes to the circle, is always half of that central angle up there. Part 5, you concentrate at the start of this on this quadrilateral here. So any quadrilateral, now you'll notice it's not a cyclic quadrilateral because only 2 of the points are actually on the circle. So a cyclic quadrilateral, 4 points have to be on the circle. But any quadrilateral adds up to 360 degrees, the internal angles. You're given 90 degrees, 90 degrees, and 75 degrees. So you basically take all those away from 360. So take away 90, and take away 75. And that is going to give you a princely sum of 105 degrees. So that's what A is, 105 degrees. B, using, if I get rid of all of this here, using our theorem on center angles, and if you take this point here and this point here, you can see that this angle and this angle here share the same base. This goes to the center, so angle A is twice the size of angle B. So you take 105, you divide it by 2, and you get B is equal to 2.5 degrees. Okay. Part 4. Again, we can see a quadrilateral here. So we're going to use the quadrilateral rule because we're given 3 of the angles and A is the 4th one. So A is 360, take away again 90, take away another 90, and then take away 82, and you're left with 98 degrees for A. Angle B here. So this and this line are both radiuses, so you have an isosceles triangle. So these 2 angles are both exactly the same. They're both whatever angle B is. Now you know what A is. You know it's 98 degrees. This angle up here is, you have a straight angle. You have a straight angle there. Okay. You are taking away 98 degrees from that. And, sorry, from 180 you're taking away 98 degrees. And that gives you 82 degrees. So this angle up here is 82. And once you know one angle in an isosceles triangle, you're able to work out the other 2. Okay, so 180 minus 82. That gives you the sum of B and B. Okay, so that's 98. And then you divide that by 2 and you're going to get 49 degrees. Okay. The other way that you could have done that is that the exterior angle is equal to the sum of the two opposite interior angles. Now, in this case, my exterior angle is 98 degrees. The two opposite interior angles are both going to be the same size because it's a equal isosceles triangle. And 98 divided by 2 gives you the angle B. So the last part, I've given extra space for this because this is definitely the most complicated one. You are given one angle and you have to work out what A and B is here. Now there's a few things that you have to spot before you go on with this. And the first thing is that this line here is a radius. Okay, so when you look at this, what I've done in blue, that is an isosceles triangle. And they don't tell you that in the question. Now, because that's an isosceles triangle, you're able to work out this angle down here and this angle down here. Now, they're not asking you for that, but you're going to have to work that out. Because once you work out this angle, it will give you what this angle is, and because this is an isosceles triangle, that then leads you on to A. So let's come back here. We know that the top angle is 112 degrees, so take that away from 180 degrees and divide it by 2. That gives you, 112 away from 180, divide it by 2, and you get 34 as your angle in here. Okay. Now, let's get rid of all this nice blue here because I want to show you what's happening here in green. If you take this angle up here, okay, so if I draw that down there, and if I draw this angle up here, you can see that I have two angles that share the same base, this point and this point. So this angle here and this angle here are going to be identical. Now we just worked that out at 34 degrees, so therefore this is 34 degrees. That is always worth looking out for. That pattern. It's hard to spot when it's mixed up in a complicated pattern like this. So once we have that angle here, we know that this is the same as angle A. Okay, and the reason for that is, again, if I go back to I'll just highlight this here, you have a isosceles triangle there. Now, why do you have an isosceles triangle there? Because in the question they tell you that this length and this length down here are identical. So this A is now 34 degrees. Now that's a couple of steps just to get to A. So B, what do we do with B? Now, if I get my highlighter out here again, and if we look at this triangle, that's a 90-degree triangle because I have a diameter here, and any triangle that sits inside a circle with its base as a diameter, you always have a 90-degree angle there. So, if I know that that's 90 degrees, why does that help me? Well, I know from here before that this was 34 degrees. Therefore, this here is 34 degrees. This total angle up here is 90 degrees. So this has to be 56 degrees here. Okay, so that angle there is 56 degrees. 56 and 34 give you 90 degrees. Now, here within this triangle, I have now got two of the three angles within that triangle. And when I work that out, this turns out to be 90 degrees here. When that is 90 degrees, straight angle here, 90 plus what gives me 180. B has to be equal to 90 degrees also. Okay, so B is the opposite side of this here. That has to be 90 degrees. That's, I would consider, something that you could possibly get in the Leaving Cert. It is complicated enough, and it really requires you to take your time and look at what you know, what's there. Look at patterns. So look, especially being able to spot this. That comes up a lot. You have another pattern here of that where you have that going to the center and then this angle over here. So this angle is twice this angle here. Okay. And again, hard to spot that when you're in the middle of a question, but again, it's the common base. That's the clue there on that. Okay. Go back over those. They're well worth learning off.